I'm Josh Halley. I'm a solution architect with Cisco, working in CX, which is a project team. We do different projects around Africa, Middle East, Europe, and Russia. Presentation I have today is to talk about how not to actually do a BLE survey. The reason why I have the word not here, and this is probably the biggest question about this presentation, why are you presenting how not to do a survey? This is definitely not a fantastic way to do things. Don't get me wrong. But it's one of the best ways that we have today to actually achieve our goals. So the type of site surveys which I'm targeting, I'm looking at in the context of BLE is proximity location. How do you make that measurement, identify that sweet spot to ensure that the proximity location beacons trigger your application, trigger your system to notify you of something without making the reach too far or having it trigger within the wrong location? So the foundation for this is actually having the right components. So to get started out, number one, you need Wireshark. Sounds messy already, right? You need a BLE sniffer. And you need a reference device. You need to understand what is the likely RSSI which is going to be received from the client device in comparison with your sniffer, which you're using to measure and identify your particular RSSI average within a particular location on your map, and clearly a floor plan to scale with the right measurements. Now, the adapter which is depicted here, as you can see, it's a lot of circuit board, but I tested various different types of adapters, and this one was relatively stable and was able to provide us with a consistent experience in the context of measuring BLE packets. Now, if we look at the different types of frames, depending on the vendor, depending on the BLE type of beacon, I was working heavily with battery-powered beacons for some of my projects and deployments. They send different types of packets. You've got your connectable packets, which are being transmitted from your BLE beacons, which allow an end device to potentially connect up. Then you have your non-connectable packets, which here are depicted under ADV non-con. And you're going to see these different packets and some of the traces which we're going to get to. So understanding the types of packets associated with the beacons you're using, regardless of which manufacturer it is, understanding these attributes will help you understand how do I work out where my beacon is within my location, and how do I find that sweet spot to be able to say this is the starting point and this is the end point of where my device will trigger based on an application recognition. So the different values that we look at here, we've got an attribute which is the UUID, the universal unique identifier, and this identifier is used to distinguish typically a beacon from a manufacturer with a variable field that you can change to match your respective organization. So when you're deploying your beacons throughout a location, you'd be using the UUID field with the marker matching your installation for the different beacons which you decide to deploy throughout your site. Further to this, you've got other variable attributes that you can change. You've got the major fields and the minor fields. A major field you would typically configure for a floor or location. The minor fields would be a per device attribute, so you can recognize beacon 1 versus beacon 2. On an application level, things get more detailed depending on what type of application you're using. Are you using an iPhone or an Apple-based context application? For them, they use what's called nominal distance, and within that API, within the program, you can use nominal distance to somehow, within the application, trigger on what RSSI it's going to kick off and provide you with a notification. In my experience, you want to go with the hard RSSI and testing manually, because how it's going to trigger based on your iPhone, based on your different devices, and through that API, it's always a little bit dubious. So how do we actually do this? As I mentioned, we have to have a look at the packets. So you want to understand what type of frames are you receiving, and how are those frames put together? I've seen all sorts of weird beacons out there from different manufacturers, some which are using the same MAC address, regardless of how many you order. Makes it a little bit difficult to determine which device is where, and also use your traces to identify them. So to get around this, you want to use the characteristics that you know. If they only send out ADVINVs, use that as your capture attribute to work out these are our beacons and not something from a third party. It's quite common from all manufacturers that they've got some level of beaconing within their APs, and this can mix up your results if you're not filtering correctly. Okay, so understanding these details, understanding the addresses, this is key in being able to determine what characteristic am I going to filter on. Now, applying these filters, in my experience, because you're actively surveying using Wireshark, some of the nice tools that we have out there, you have to rely on looking at the live Wireshark traces to see what's coming through. So if, for instance, I have 2 or 3 different beacons within my area and I want to work out their respective RSSI, I mark the different characteristics, UUID, major, minor, or the respective to address, assuming that it's present, and then use that as a characteristic to say, okay, this is beacon 1, this is beacon 2, this is beacon 3, and I color them accordingly using rules within Wireshark. So I have my capabilities to configure my different filters based on these different attributes, but sometimes it's not enough. For instance, if an application is programmed to always use the same UUID, major and minor fields, then you're kind of stuck. You don't have much else to go on. So as a result of this, you may need to dig deeper into your packets and apply filters basically directly on the data fields. So you've got your data fields here within your actual beacons, and you can use those fields and select those specific fields when you're surveying to measure the different devices and understand where your different mapped beacon or respective RSSI is coming from. Within Wireshark, there is the concept of what's called a dissector, which allows you to basically translate the different data fields based on bytes and everything else. You can customize this, and there's nothing stopping you from doing this, but in this context, I'm showing you the raw fields, which you basically pick up from the beacons which you're using from whatever manufacturer, and then you can build your dissectors or whatever else as you may need them. So looking here, an example of some of the results which I gathered. So basically, we can see different beacons based on different colors and the respective RSSI which was received from each one of these beacons, and the fantastic way, which we use to actually work out where the good and bad locations are on your map, is based on basically manual notation. This is my beacon number 1. I'm receiving an RSSI of 61 to 65 in this location. When I stand there, that's my average, based between there. 67 to 69 when I move a few meters across. So we need to keep in mind, you'd never do something like this for a Wi-Fi installation. We've got better tools for this. But given the limited resources and capabilities that we have for BLE, this is one method that you can potentially use to work out where will my beacon trigger and where will it not. We've seen proximity used heavily in museums. In art galleries, they put a beacon behind a painting and then you get a notification this painting was from this artist or whatever else. But working out that sweet spot, at the moment, there's not a large array of tools out there which actually provide this information. Now, one last thing, I'm almost finished, sorry, is we have had scenarios where the beacons, no matter what you do, they're still way too strong. So you have to manually attenuate them. This is the method, old trusty, yeah. So basically that's it. It's not a fantastic way of doing things, but sometimes your hands are tired. It does work. It involves a bit of work and packet sniffing, but ultimately it brings you to the goal that you want to reach.
How do you tie your location to the chunk of Wireshark frames?
So basically, within Wireshark, if you right-click any frame, you have the capability of adding what's called packet comments. So while I'm walking around the floor and I find this particular frame, okay, it's a minus 67, I'd add a packet comment when I arrive at that location. And then again, when I change location again, I'd add a separate packet comment. Exactly, so in that packet comment, I know from here onwards, this is location 1. From the next point onwards, it's location 2, and then start looking through the Wireshark capture at the end of the packet comments to see, okay, this was associated from location 1 or location 2, and so forth.
Thank you.
You're very welcome.